Ka and Kb. So Ka, it's defined for, this is called acid dissociation constant. Ka, acid dissociation constant, acid dissociation constant, defined for acids as and defined for cations. Kb for anions. Kb for anions. So Ka, acid dissociation constant. Last class I told you where now, for example, CH3COOH, right? So undergoing CH3COO minus H plus, acid, right? So directly I am writing Ka is equals to CH3COO minus H plus ion concentration by CH3COOH. This Ka. So this is only mono basic acid, means only one H plus is giving. In case of H2S, H2S gives rise to HS minus H plus. Okay, this we can say Ka is equals to Ka1. Ka1 is equals to HS minus H plus ion concentration by H2S concentration. H2S concentration. So once again we can write like this: HS minus gives rise to, right, S2 minus plus H plus. So this we can say Ka2 is equals to concentration of 2 minus H plus ion concentration by HS minus concentration. So Ka1 and Ka2 is getting like this. Generally, so most important thing is Ka1 is greater than Ka2. Ka1 is greater than Ka2 and Ka3 also is there. We can write the Ka3 also. If Ka value is more, strength of the acid is more. If Ka acid is, the Ka value is more. If Ka value, the Ka value is more. If the Ka value is more, the strength of acid is more. Strength of acid, the strength of acid is more. Right, one more Ka3 also we can write like this, H3PO4 gives rise to H plus plus H2PO4 minus. Okay, so in this case I'll writing Ka1 is equals to H plus ion concentration H2PO4 minus by H3PO4. This is Ka1. Now we can write for this Ka2 also. How? H2PO4 minus gives rise to H plus plus PO4 2 minus. Okay, Ka2 is equals to H plus ion concentration PO4 2 minus concentration by H2PO4 minus. And one more also we can write. What is that? Ka3, like it is HPO4 minus. HPO4 2 minus gives rise to H plus plus PO4 3 minus. So in this case Ka3 is equals to H plus ion concentration PO4 3 minus ion concentration by HPO4 2 minus concentration. Now Ka1 greater than Ka2 greater than Ka3. So here is one more important thing, right? Ka1 is always greater than Ka2. Write it down. Already I told you Ka1 greater than Ka2. In all these cases, H3PO4 and H2PO4 minus. In these two cases, which is strong acid? Means which is more Ka value is more means. Because this is acts as only acid. But this is acts as acid as well as base. Means it can give the H plus, it can take the H plus. Okay? It acts as a acid as well as base. It acts as a acid as well as base. So Ka value always Ka1 is greater than Ka2. Next one, case 2 for cations I told you. NH4 plus, we are doing the hydrolysis. What we will get, Nana? NH4OH plus H plus. Right? So in this case, we could say Ka or we can write KH, hydrolysis constant, KH. Ka or KH is nothing but you can write concentration of NH4OH, H plus ion concentration by NH4 plus concentration. NH4 plus concentration. KH is nothing but hydrolysis constant. No? So this we will do in the salt hydrolysis. No? Salt hydrolysis we will discuss that. So Ka is, we can apply to this also. KH is nothing but hydrolysis constant. Hydrolysis constant. Hydrolysis constant. Next one, Kb. Kb is defined for Kb. The base dissociation constant. Base dissociation constant defined for bases and anions. Bases and anions. Kb. NH4OH gives rise to NH4 plus OH minus. Kb is equals to, so generally we'll take the die, of course, C minus, C alpha, C alpha, C alpha like this. So Kb is equals to NH4 plus concentration OH minus by NH4OH concentration. So like Ka1 greater than Ka2, like Kb also is there. Kb2 also is like this. Zn OH twice gives rise to Zn OH plus OH minus. Okay. Kb1, directly I am writing Zn OH plus OH minus by Zn OH twice now. This is Kb1. Next Second case, Zn OH positive gives rise to Zn2 plus OH minus. So Kb2 Zn2 plus OH minus by ZnOH positive. So same like Ka1, it is Kb1 is greater than Kb2. Kb1 greater than Kb2. Same Nana. So this is defined for anions also, I told you, right? For example, anion CH3COO minus on a hydrolysis, anion hydrolysis also we could say will get CH3 COOH plus OH minus. In this case, Nana, Kb, or we could say the KH. So concentration of CH3 COOH OH minus and concentration by CH3COO minus concentration. Next, Nana, put the heading pH and pOH. So H plus ion concentration, pH and pOH. Hello. The concentration of H power, H plus ion, write it down. The concentration of H plus ion, is expressed in terms of negative power of 10. And numerical value, and the numerical value that of negative power is known as, the numerical value of negative power is known as pH. Is known as pH. It is H plus ion concentration will express like 10 to the power of minus x. So x is nothing but here is pH. We could say H plus ion concentration is equals to 10 to the power of minus pH. Write it down, 10 to the power of minus pH. So if you apply the log H plus is equals to minus pH. So pH is equals to minus log H plus. Right, Nana. So pH is equals to minus log H plus ion concentration. Okay. Hello. So here is pH is equals to always pH is inversely proportional to H plus ion concentration. The stronger the acid, the pH is low. So generally the pH scale is like this, 0 to 7. So means like this, pH is like this. pH is decreasing. So for example 1, 2, 3, 4, 5, 6, right? If the H plus and pH concentration is increased, pH is 6 means what? For example, two acids are there, pH is equals to 2, one is pH is equals to 4. Which is stronger acid? pH is equals to 2. This is stronger acid. So pH is inversely proportional to H plus ion concentration. So to solve the pH calculations, Nana, so we should know the log values, Nana. Log values. Log 2. Log 2. How much, Nana? 0.3010. Log 3. Log 4. Log 5. Yeah, come on, tell me. Log 2 0.3. So log 3 0.48. 0.48. Log 4 0.7. 0.6, right, sir? Log 5 0.7. This is double, right? Log 2, log 4. Next one, POH. POH. Same like OH minus ion concentration. OH minus ion concentration is equals to, right, 10 to the power of minus Y, like minus Y is nothing but POH. OH minus ion concentration is equals to 10 to the power of minus POH. So if you are writing the log POH, log OH minus is equals to minus POH. POH is equals to what? Minus log OH minus and concentration. Write it down. So for example, here is a very important question here I am writing you. H plus ion concentration, for example HCl or anything. Concentration is given 2 into 10 to the power of minus 3. What is its pH now? What is its? Come on, let me know. Nothing but H plus ion concentration. Just take is H plus ion concentration is equals to this. 2 into 10 to the power of minus 3. Let you know so how we need to solve in a logical way of this question. It's easy one only. Two ways I'll explain. So a lot of people, they know only one method, that is pH is equals to minus log H plus ion concentration. Right? So minus log 2 into 10 to the power of minus 3. Nothing but 3 minus log 2. So nothing but 3 minus 0.3. Log 2 value 0.3. Nothing but 2.7. This is everyone will do in this. This is the proper method. But I'll tell you one more method. Okay? So this is important method, no? To solve in a easy mode. So H plus ion concentration is equals to 2 into 10 to the power of minus 3. So now we know that what is log 2? Log 2 value is how much? 0.3. 0.3. Yes or no? So if we'll write the in terms of log 2 power, how can we write? No? Hello. So can I write 10 to the power of 0.3? 10 to the power of 0.3 into 10 to the power of 3. Right? So means what? 10 to the power of minus 2.7. I told you H plus ion concentration. What I told here? H plus ion concentration is equals to minus pH. Yes or no? So directly we could say pH is equals to 2.7. Got it? So this point is important. You know? We need to understand this. How I write the 2 is nothing but 10 to the power of minus 3. If we know this logic, we can solve any type of question in an easy mode. But a lot of people missing this point, this particular point. Log 2. So when log nothing but what? 10 to the power of x. 10 to the power of x. So here is 2, 0.3, just 10 to the power we are just writing. Okay? Got it, Nana? Any doubt? Right. So now what is the relationship between pH and POH? What is the relationship between pH and POH? We'll do more questions on the pH calculations, of course. So before going to that, ionic product of water, write it down. Ionic product of Ionic product of water. If water undergoes like H plus plus OH minus, so if you are writing K is equals to what, Nana? H plus ion concentration, OH minus ion concentration by H2O. But water is highly negligible now. So dissociation of water is highly negligible, is almost all constant. So we will take H2O is almost all constant more. So K into K, both are constants, we'll write KW. KW is equals to H plus ion concentration into OH minus ion concentration. KW is nothing but ionic product of water. KW is nothing but ionic product of water now. Just write it down. KW is equals to ionic product of water. Write it down. KW is constant. KW is constant. Its numerical value, na? Its numeric value only depends on temperature. Only depends on temperature. Very, very important point, 5-star point. KW, its numerical value depends on only on temperature. At 25 degrees centigrade, at 25 degrees centigrade, so particularly we need to mention the temperature. 25 degrees centigrade, KW is equals to 10 to the power of minus 14 at 25 degrees centigrade. So at 25 degrees centigrade, so for example, this pKW is nothing but what? Minus log KW. Nothing but water. pKW is equals to what? Minus log K by 10 to the power of minus 14. So pKW is equals to 40. This pKW value 14 at which K? At what temperature? Particularly 25 degrees centigrade or 298 Kelvin. 298 Kelvin. 273 is normal plus 25. Right? 278 Kelvin. At 278 Kelvin only. So we will. So we know that KW is equals to H plus ion concentration. I'll go like this. Can we say like this? H plus ion concentration and OH minus ion concentration is equals to KW. Yes or no? We'll apply the log graph. Apply both sides. Log H plus ion concentration, OH minus ion concentration is equals to log KW. So log A into B, log A plus log B, right? Log H plus log OH minus is equals to log KW. Apply minus all sides. Minus log H plus minus log OH minus log KW. Nothing but minus log H plus nothing but water. pH it is plus POH is equals to pKW. So at 25 degrees centigrade, pH plus POH is equals to what? Hello? Right. At 25 degrees centigrade, particularly once again I mentioned 25 degrees centigrade or 298 Kelvin. pH plus POH is equals to 14. So this is the relationship between pH and POH. Sometimes they are giving the OH minus ion concentration if they are asking the pH, so Based on this, we need to solve. Write it down. Log A into B is how much now? Log A into B. Not log A plus log B. Write it down there. Then this is relationship between what? pH and pOH. And write one more important thing. Relationship between pK and pKb. pK and pKb. Relationship between. So what is pKa? So instead of pKa, we'll go with the Ka, Ka and Kb. Okay. Relationship between Ka and Kb. So I told you Ka, for example, what is pKa? pK is equals to minus log Ka. pKb nothing but minus log Kb. Okay? Hello? For example, Ka value is more. Ka inversely relationship pKa value. Kb is inversely relationship. Kb is inversely relationship with pKb. So these points are very important. Based on this, they are asking the questions now. Right? If, for example, acid is strong acid. If Ka value is high, Ka value is high, then by default pKa value should be pKa value low. When pKa value is high, pKa value is low, so then acid is right, Ras? Acid is equals to strong acid. Strong acid. So now we'll discuss what exactly the relationship between Ka into Kb. Ka is defined for acids. Kb defined for bases as well as anions. Right? We'll discuss that. For example, this is right important. CH3 COOH. This is acid. CH3 COO minus H plus. Okay. So in this case, we'll write K, acid dissociation constant. And I'm writing CH3 COO minus anion. On hydrolysis, I'll get CH3 COOH plus OH minus. This I would like to say Kb. I told you that Kb is defined for, right, bases as well as anions. I told you in this class only. So for example, if I am adding the two equations, I told you when we are adding the two equations, Ka and Kb will becomes what? This CH3COO minus, this COO minus will get cancelled. This CH3COOH, this also get cancelled. What are remaining? What are remaining? H2O gives rise to H plus plus OH minus. H plus plus OH minus is nothing but what? H plus plus OH minus. Nothing but Kw is equals to Ka into Kb. Write it down this. Kw is equals to Ka into Kb. This, because to know this value, so I am just writing this. Kw is equals to Ka into Kb. So same like Ka into Kb is equals to Kw. Apply the log both sides now. Minus log I am directly writing. Right? If we are writing log Ka into Kb is equals to log Kw, right? So log Ka plus log Kb equals to log Kw. Apply the, right, multiply with negative, minus log Ka plus minus log Kb is equals to minus log Kw. So nothing but pKa plus pKb is equals to pKw. Write it down. pKa plus pKb is equals to pKw. So this value and this value is very important. Same no, Ka value is high means pKa value is low. Same like Kb also same thing. If Kb value is more, pKb value is less. If the Kb is more means pKb is less, means nothing but that is strong base. Strong base. They are asking lots of questions based on Ka, Kb, pKa and pKb. Write it down. So we discussed today Ka is acid dissociation constant, right? This is defined for acids as well as cations, right? So pKa nothing but minus log Ka. I already told you, if the Ka value is high, pKa value is low, means that acid is stronger acids. For example, is Ka values are there, some values are numerical value. So 1, for example, acid 1, 3, acid 2, 5, acid 3, 6. So 1, 2, 3, which is strong acid here is? Which 3 is the stronger acid. Okay, for example, pK 1, pK value I am giving you. 2, 5, 8. Which is stronger acid? Ka. The value is high means that is strong acid. The pKa value low means that is strong acid. Right? Write it down. If the Ka value is high, that is strong acid. If the pKa value low, that is strong acid. So means I told you that Ka is inversely proportional to pKa. Ka is inversely proportional to pKa. Next, we discussed H2S like this. Next, Ka1, Ka2, Ka3, Ka1 is always greater than Ka2 and Ka3. This is also very important takeaway point. And for cations, K and KH, Kb base dissociation constant. Here is also, for example, the Kb value 1, 2, 3. This 3, 4, 6 for example is given. Which is strong base? Which is strong base? Right? This is the strong base. 6. Kb is inversely proportional to no? Hello. pKb. Sorry. pKb. Kb is inversely proportional to pKb. If the Kb is high, pKb low, means that is strong base. Strong base. Exactly opposite. What exactly opposite? What is opposite? Kb is low, pKb is high. That is weak base. So Kb1 greater than Kb2, of course I already discussed this. So CH3COO minus H2O, right? So here also we discussed this pH and pOH. H plus ion concentration is equals to 10 to the power of negative value. Is nothing but this is very important. Log 2 values, these values we should know. pOH we discussed. Okay na? Ionic product of water. pH plus pOH is equals to 14. And pKa plus pKb is also pKw. So based on this, try to solve some numericals, and tomorrow purely I will go with only pH calculations. pH is very important for strong acids weak acids, mixture of strong acids, strong acid and weak acid, mixture of weak acids. So different cases, acid plus base if they are mixing, and for bases also we can calculate the pH. How? First we need to calculate the pOH, and pH plus pOH is equals to 14. Based on that we need to calculate the, so those things we'll discuss tomorrow.